This is me again, Miss Rhiannon. I'm back to discuss the characteristics of the roots and relationship of coefficients to the roots of quadratic equation. But before that, we'll be reviewing first real numbers. Real numbers consist of rational numbers and irrational numbers. For rational numbers, we have the integers. Examples: the negative integers, -1, -2, -3, -4, and so on. Under integers, we also have the whole numbers. The whole numbers consist of 0 and the positive integers 1, 2, 3, 4, and so on. Under rational numbers, we also have fractions. Examples: 1/2, -3/5, 7/4, 3, and 1/3. 1/2 and -3/5 are examples of proper fraction. 7/4 is an improper fraction. 3 and 1/3 is a mixed number. Next, under rational numbers are the decimal numbers. For decimals, we have the terminating decimal. This has a finite number of figures, and the non-terminating decimal. This has infinite number of figures. Under real numbers, we also have irrational numbers. These numbers may include radicals because radicands are not perfect square numbers. Examples: square root of 2, square root of 3, and negative square root of 5. Of course, pi is also an example of irrational numbers. Next are imaginary numbers. These numbers are not real numbers. Examples are the square root of negative numbers, square root of -1, square root of -2, square root of -3, and so on. Aside from that, we also have number that has I. Examples: I, 2i, 3i, and so on. We'll now be determining if the following are rational, irrational, or imaginary. -3.6. Yes, rational number. Next, square root of 4. Very good, rational number. How about the square root of 8? Yes, an irrational number. Why? Because the radicand 8 is not a perfect square. Next is square root of -9. Yes, very good, imaginary number. Why? Because the radicand is a negative integer. Therefore, square root of -9 is an imaginary number. We'll now be discussing the nature of roots of quadratic equation. From the quadratic formula, x is equal to -b plus minus the square root of b squared minus 4ac all over 2a. We have to take a look at the radicand. The radicand b squared minus 4ac is actually called the discriminant. The discriminant b squared minus 4ac describes the nature of the roots and the number of real solutions of a quadratic equation. If b squared minus 4ac is equal to 0, the equation has one real root of multiplicity 2, and they are real, rational, and equal. If the discriminant is greater than 0 and a perfect square number, the equation has two real roots. Both are real, rational, and unequal. If the discriminant is still greater than 0 but not a perfect square, the equation has two real roots, both are real, irrational, and unequal. Lastly, if the discriminant is less than 0, the quadratic equation has no real roots. Now we have to describe the nature and the number of real solutions of x squared minus 10x plus 25 is equal to 0. This equation is already in standard form, so we'll now be identifying a, b, and c. A is equal to 1, b is equal to negative 10, c is equal to 25. These values will be substituted in the formula b squared minus 4ac. b is negative 10, a is 1, and c is 25. So negative 10 squared is 100, and negative 4 times 1 times 25 is negative 100. 100 minus itself is equal to 0. Therefore, the discriminant of x squared minus 10x plus 25 equals 0 is 0. So, the roots are real, rational, equal. The equation has one real root of multiplicity 2. Our next example is x squared minus x is equal to negative 2. To find the nature and the number of real solutions, we have to rewrite first this equation in a standard form. To do it, we have to add the additive inverse of negative 2 to both sides of the equation. The additive inverse of negative 2 is positive 2. On the right side, we have negative 2 plus 2, which is equal to 0. So the final equation will be x squared minus x plus 2 is equal to 0. Now we'll be determining a, b, and c. A is 1, b is negative 1, and c is 2. We'll be substituting these values in the formula d is equal to b squared minus 4ac. b is negative 1, a is 1, and c is 2. The square of negative 1 is 1, and the product of negative 4, 1, and 2 is negative 8. To simplify 1 minus 8, we have negative 7. So, the discriminant is negative 7. The discriminant is less than 0. So the equation x squared minus x is equal to negative 2 has no real roots. Next, we'll be discussing the sum and product of roots r sub 1 and r sub 2. We'll be using the formula for the sum of products r sub 1 plus r sub 2 is equal to negative b over a. And for the product, r sub 1 times r sub 2 is equal to c over a. Find the sum and product of roots of 2x squared minus 9x is equal to 0. And here, a is equal to 2, b is equal to negative 9, and c is equal to 0. We'll be substituting these values in the formula. R sub 1 plus R sub 2 is equal to negative b over a. b in here is negative 9, and a is 2. Negative times negative is positive. And since there is no other common factor of 9 and 2 aside from 1, then 9 over 2 is the simplest form. The sum of the roots now is equal to 9 over 2. For the product, we have c over a. Our c in here is 0 and a is 2. 0 divided by 2 is 0. So the product of the roots is 0. Next example, x squared minus 11x plus 9 is equal to 0. This equation is already written in its standard form, so we'll just be identifying a, b, and c. A in here is 1, b is negative 11, and c is 9. For the sum of the roots, we'll be using the formula negative b over a. b is negative 11, and a is 1. Negative times negative is positive, and 11 divided by 1 is 11. Therefore, the sum of the roots is 11. For the product, we have c over a. c in here is 9, and a is 1. 9 divided by 1 is equal to 9. So the product is equal to 9. Now we'll be writing the equation in the form ax squared plus bx plus c is equal to 0, given the sum and product of the roots. The sum is 0, and the product is negative 15. To find the equation, we'll just be substituting 0 and negative 15 in the formula x squared minus the sum of r sub 1 and r sub 2 times x plus the product of r sub 1 and r sub 2 is equal to 0. r sub 1 plus r sub 2 is 0, and r sub 1 times r sub 2 is negative 15. 0 times x is equal to 0. So the resulting equation in our final equation is x squared minus 15 is equal to 0. Next, we'll be finding the equation whose sum of roots is negative 1/3 and whose product of roots is 2/3. To do this, we'll be substituting these values in the formula. We can see here that r sub 1 plus r sub 2 is negative 1/3, and r sub 1 times r sub 2 is 2/3. To get rid with denominator 3, we'll be multiplying both sides of the equation by the LCM, which is 3. So, 3 times x squared is 3x squared. 3 times negative 1/3 x is equal to negative 3 over 3x, which can be simplified as negative x. Negative x times negative is positive x. Next, 3 times 2/3 is equal to 6 over 3, and 6 divided by 3 is positive 2. Of course, we have 0 times 3, that is equal to 0. So the resulting equation in our final equation is 3x squared plus x plus 2 is equal to 0. We'll now be finding the equation given the roots negative 5 and 2. To do this, we'll be getting the sum and product. For the sum, we have r sub 1 plus r sub 2, negative 5 plus 2 is negative 3. For the product, negative 5 times positive 2 is negative 10. Now we'll be substituting these values in the formula. In here, r sub 1 plus r sub 2 is negative 3. R sub 1 times r sub 2 is negative 10. Simplifying, we have x squared plus 3x minus 10 is equal to 0. Last example, write the equation in the form ax squared plus bx plus c is equal to 0, given the roots positive, negative, square root of 13. For the sum, square root of 13 and negative square root of 13 are additive inverses, so the sum is equal to 0. For the product, square root of 13 times negative square root of 13, we have negative 13. Why? Because positive times negative is negative, and square root of 13 times itself is equal to square root of 13 squared. The square root is 13, so the product of the roots is negative 13. Now, we'll be substituting the values 0 and negative 13 in the formula. R sub 1 plus R sub 2 is 0, and R sub 1 times R sub 2 is negative 13. 0 times x is equal to 0. So, the final equation will be x squared minus 13 is equal to 0. That's all for today. Thank you guys so much for watching.